So this machine is a shots analyzer, and its sole purpose is to test the coefficient of friction in a fastener. So when we're looking at different coatings or finishes, we generally have a friction range that we want to stay within for critical joints. And this machine will allow us to separate out the friction in the bearing surface, which is under the head, and in the threads separately, and then it can calculate total friction as well. This particular machine can test anywhere from an M30 bolt, or about 1.25 inches, and down as small as M6 bolts, so we have quite a range. A lot of the machines you see out there in the industry that do this kind of testing only are set up for M10 surrogate bolts. So we can actually test full-size samples on this rig. So what I've gotten here, we're going to show you the difference between a plain finish bolt, which is going to have some oil on it, and it's going to have a lower friction, and a electroplated bolt, which is a high friction finish, and we'll show you the difference between the two. How this works, we will put the bolt in through what we call a sledge. This is a hardened machine plate. Every time we do a test, we'll surface this plate so it's a nice, dry, smooth, clean finish. And then we'll run the bolt head through here, through the load cell, and then we'll put a nut on the back side, which is also plain and clean and dry per the standard. So we've got the plain one already set up to run, so we just push the button. That's all there is to it, and then we can look up here and we can see the results. So the two samples that I ran, on the far right is our total friction, and then the UTH is thread friction, and the UB is bearing friction. You can see we ran both of them to the same load, which is 85 kilonewtons of load, the bearing friction, and they were the same on these. And then the thread friction was considerably different. One of them had a lower friction of 0.11. So then the total friction dropped down on that one to 0.13 versus 1.5. And you can see the amount of torque it took to get to those clamp loads, and this is what it becomes important to an engineer, is it took considerably less torque on this one with lower friction. It took 240 newton meters of torque to get to the same clamp load as the one with the higher friction that took almost 280 newton meters. So that's what this is all about. We can test to make sure that the fasteners meet the standard, but we can also test some actual applications if we have a certain nut and bolt combination, and we can compare and contrast the differences between those different types of fasteners.